A polynomial given by this has real coefficients. So that's a, b, c, and d are all real. 3 of the roots are 1, 2 plus I, and minus 3. Determine the values of a, b, c, and d. So, first of all, the fourth root is going to be 2 minus I by the conjugate root theorem. So we now have all 4 roots. So one possibility, one way to do this, would be to take p of x. We know it's going to be of the form x minus 2 plus I, x minus 2 minus I, x minus 1, x plus 3. Expand that out and see what it simplifies to find these 4 values. For now, I'm going to use the sum and product of the roots, though, just to show you a different way to approach this particular problem. So first of all, we know that the sum of the roots is equal to minus 1 to the power of 1, always over the leading coefficient, and it's jump 1 back, which is a. So the sum is going to be equal to minus a, and that is 1 plus 2 plus I plus 2 minus I minus 3. So minus a is equal to 4, 5, 2. So a is equal to negative 2. The product is equal to minus 1 to the power of 4, because there's 4 things being multiplied together, 4 roots, always over 1, and it's 4 away, so 1, 2, 3, 4, which is equal to d, which is equal to 1 times by 2 plus I times 2 minus I times minus 3. 2 plus I times 2 minus I is equal to 5, times by minus 3 is equal to minus 15. So d is equal to minus 15. To work out b and c, we have to do, using this method, we would have to do things like root 1 times root 2 plus root 1 times root 3 plus root 1 times by root 4, and then all of these pairs. Now, whilst that is doable, actually I think in this case that's going to get a little bit more complicated. So rather than doing that, let's try another approach. I could fall back on what I said originally, which was doing this. That would work, but I'm going to try and do it a different way. And I'm going to use the fact that I know that these are roots. If I know that these are roots, that means when I substitute these in, I get 0. So that means I know that p of 1 is equal to 0. That means that 1 minus, remembering that a is minus 2, so that's minus 2, plus b plus c minus 15 is equal to 0. So I've got b plus c is equal to 16. Similarly, I know that p of minus 3 is equal to 0, which means that minus 3 to the power of 4, it's 81. Minus 3 cubed is minus 27 times by a, so that times by minus 2, so that's going to be plus 54. Then I've got plus 9b minus 3c minus 15 is equal to 0, because this is a root. So that gives me 9b minus 3c is equal to, adding all these up, we get minus 120. I've got simultaneous equations in b and c here, so I can solve these. So I've got 9b minus 3c equals minus 120, and 3b plus 3c is equal to 3 lots of 16 is going to be 48. If I add these two together, I get 12b is equal to minus 72. So b is equal to minus 6. And finally, b plus c is equal to 16. So minus 6 plus c is equal to 16. So 6 there. So c is equal to 22. Putting that all together, I had a is equal to minus 2, b is equal to minus 6, c is equal to 22, and d is equal to minus 15. Now, as I said, I could have done this by just expanding this out and getting those 4 values. That would be a perfectly valid way to do it. Maybe it would be a bit quicker, not really sure. But I just wanted to show you other approach to take to this problem using the sum and product of roots, which can sometimes be a little bit more efficient in getting to the correct answer.